I gave you a little hint here. We're going to be using this. And again, whatever angle we're trying to find has to go with this opposite side over there. The letters don't matter other than if you have the same letter in two different places, that side goes with an opposite angle. So we've got a triangle KMM, and sometimes I just start by drawing a random triangle. And I label the sides. Even if it's not to scale, and I purposely drew this one, and I'm going to find out I did a bad job of drawing my scale. Because apparently this is 16, and this side that looks longer than 16 is 11. And this side that looks really close to the 16 is 6. How accurate was I? Not very good at all, but it doesn't matter. Right? We need a triangle. I know that I'm not drawing it to scale. These are all with centimeters. I could add my units here to help remind myself in the end that I should have the units. And I want to find angle M. Do you see that we have the three side situation, side, side, side? I don't know it's a 90 degrees. I can't use SOHCAHTOA. If I want to use the sine law, I need an angle and an opposite side. I have no angles. Absolutely, I can't use the sine law. So I have to use the cosine law. And the cosine law has its two different versions that are exactly the same, but we use this version when we're finding an angle. So if I want to find angle M, I would write cos of M. And on this side, the very first thing I'm going to make sure I write down is that the 11 squared is opposite the M. That has to be what's subtracted. Then what I use for the other ones, doesn't matter which one I do first. Please take out your calculator, because I want you to type this in all at once. If you have the fraction button, it makes your life a lot easier. But if you don't, I want you to type that whole thing in and see if you have your calculator skills up to date. If not, download the newest version at home. If your calculator skills are up to date and you push enter, you should get, I'm going to change that to a decimal. You should get 0.890625, or if your calculator does make it a fraction, you get 57/64. I'm going to write that down. But if you don't know how to use your calculator to type it in all at once, you should learn, because it's helpful, okay? Sometimes, if you do not have a fraction button, and you typed it in and did not get this, a strategy is to add, when you have more than one thing in the top of your fraction, add an extra set of brackets to make it all go together. Then when you hit the divide button and you have more than one thing that you're dividing by, also put that in a big set of brackets. If that still doesn't work, make sure you go home and download the newest version. So that you're typing, like, you can't type things into your calculator. The calculator is not very helpful. Right? What's 2 plus 2? Well, I don't know where the plus button is. My calculator told me it was 8. Well, then then you did something, not that your calculator's not working. Now, according to solving from here, based on grade 11 math, and again, often teachers will skip this, and then it causes you problems later on. Okay? According to the CAST rule, my cos is positive. Can you see that the only two places would be here or here? Having trouble with the calculator? You got it? All right. According to the CAST rule, the angles will be here and here. In quadrant 1, does it make sense that in quadrant 1, they're going to be between 0 and 90 degrees? And the answer in quadrant 4 is going to be somewhere between 270 degrees and 360 degrees? I want to point this out, because technically M has two answers. But because we're solving a triangle, does it make sense that you do not have to do quadrant 4? Because it's like you can't have an angle over 270 in that triangle. It's impossible. But I want you to still think about your CAST rule and where the answers are every time. Because with the sine law, sometimes they both quadrant 1 and quadrant 2 work. With the cosine law, quadrant 4 is never going to work in a triangle. Like, it's just obvious you can't have one angle in your triangle already over 270. But you still have to think about that. So you'd find your reference angle, and in quadrant 1, does it make sense that your reference angle is exactly the same as your actual angle? So I can write, and maybe I'll write it with a little r here. My reference angle for M is going to be cos inverse of 0.890625. And then my reference angle equals my angle, so I'm going to just go to my calculator. I'm going to go cos inverse, second cos inverse, and I'm going to take this answer, 27.048. What were we asked to round to? To the nearest degree. So I didn't have to also find 333 degrees. I can write it down, even though I have to X it out. That the only answer is the 27 degrees. So cosine law for finding an angle is really quite easy. You plug things into the formula and you make sure that the opposite side goes in the right spot. The other sides don't matter where they're going to go. And once you have that, how do you find cos of M? Well, you think of your CAST rule. It has two possibilities, but you can already cancel out possibility 1. You think of your reference angle, but you also can ignore your reference angle, because your reference angle in quadrant 1 is exactly the same as your angle. But I still want your brain to think about reference angles and CAST rules, because if you skip thinking that, when you need to use your reference angles and CAST rule, you might skip thinking that. Okay, let's do part B. Is everybody okay if I just erase part A here? Everybody has it down? Part B, we have a triangle stew. So I just make some triangle stew. ST is 16. SU is 20. TU is 6. And this time we're finding angle T. You see this is almost identical question to the last one. We have to use our cosine law. And when I set it up, I'm finding angle T. if this is the angle I'm finding, this is the opposite side. So my formula, that has to be the minus part, minus 20 squared. The other sides, won't matter. What's going to be interesting in this question is is it like, nice. I'm going to steal it from last time because the numbers are very similar. Oh, there's something cool that happens. Negative. So if we had this answer, and I tried to change that to a decimal, I would get cos of t equals negative 0.565. Here, the negative's going to make a difference, because according to your CAS rule, it is either in quadrant 2 or in quadrant 3. I hope that you'll know this one doesn't work because quadrant 3 goes over 180 degrees. Not possible in a triangle. But we do need to find our reference angle. Okay? We find our reference angle by doing what? Cos inverse of positive. So really important that with the reference angle, we always put in a positive value. So go to my calculator here, and I'm going to do cos inverse. I'm not going to steal that answer. In fact, I'm going to use a fraction because it's less to type by one button. Not that much less, I guess. And I find my reference angle is 55.77 degrees. 55.771 if I use 3 decimal places. 55.771 degrees. In quadrant 2, it would be 180 minus this answer. In quadrant 3, it would have been 180 plus this answer. I'm going to write them both down for t. 124.229. And 235.771. And then I'm going to put an X through this one, because there's only one answer. And then I'm going to point out something in a triangle which, after I point it out, should make common sense to you, but you probably don't know this fact. Does it make sense that the biggest angle in a triangle, its opposite side is always the biggest? The longer I make that side, the bigger the angle it has to get. So this angle S will be the smallest one because its opposite side is the smallest. When I explain it, it makes common sense. But if I just had asked you priorly, like, oh, which angle do you think is the biggest? It might not have been obvious right away. Okay? This time we got a negative. That negative for cos told us it had to be in quadrant 2 or 3 according to the CAS rule. And of course, only 2 makes sense, which makes it an obtuse angle. If you're watching videos in other places, You might find some people who just do, watch what happens if I did cos inverse of the negative answer, and they skip the reference angle, you'll notice they get the right answer. They get the 124. But it's dangerous to do it this way because you will get questions where you have to find both answers. And if you don't find your reference angle, and you just do the cos inverse of the negative, there's no way you'd ever find the 235-degree answer. Okay? Why would I lose marks on this question? It's not a rounded property. Okay? So you finish the question, always take the time to read the question again. It says round to the nearest degree. I hate taking off marks because you decided to be lazy and not read the question again and didn't round correctly. Okay? But I feel like the math class has that in to teach you to be careful, and usually we have to take off a half a mark between 20 and 30 times per student on average before they start to realize, oh, I shouldn't do that mistake anymore. Then you do it another 10 times. Oh, I shouldn't do that mistake anymore. And you keep doing it. So we keep checking that one. Questions to circle for this one? 5 and 7. And we'll do one more.